Mhm.
All right. Hey, everyone. Welcome to another deep dive. Today we have a special guest. We have Michael with us, who's from Celer. Welcome, Michael.
Hi, welcome. Sorry. Hi, everyone. I'm very glad to be here to share a little bit of like technical design decisions and like a little bit of history, what we did, what we were doing, like what we're going to be doing the next few months, few years, all that.
Cool.
So very excited.
Well, how did the one thing I did want to ask, because like Celer, I knew Celer was a Binance Labs company back in the day. They were a Binance Labs company when us, Teller, we were actually in Binance Labs with them. And what was the journey, I guess, from, because what was Celer originally, and then where did it kind of end up now, and what was some of the decisions along the way?
Yeah, I guess it's been a quite long journey. So we are a project. We were founded in 2018, and initially we did state channels, which is kind of like this OG like scalability solution, which stemmed from like the Lightning network on Bitcoin, and then it get ported over to Ethereum and gets called like say the Raiden network or whatever like term that used to be called. And yeah, so initially we started off as we call like generalized state channel scalability solutions. So what we did was we scale like not only payments, but also like general smart contracts. So the very first demo we did was a little like Gomoku game that is like off chain. So like you make all the moves off chain, like you in the optimistic case, you don't have to even go on chain for like the resolution of the game. So like you only go on chain when there is some kind of like dispute or some kind of like a disagreement between the two parties. So that was the like original idea of generalized state channels, and that was kind of like our showcase application of our scalability solution. So yeah, it worked quite well for like micropayments, and it worked quite well for like the games like Gomoku, like the one I described. And we actually built a kind of like a gaming platform on top of it, so like people can play mini games and doing like micro payments, like all like off chain on top of this like a state channel network we did. So yeah, that was like the original like version of Celer. And then like we were just kind of like while we were like building this, while we were like kind of like selling this kind of product, we found that the state channels are kind of limited in terms of applications. So for example, it's very hard to model something like Uniswap. Basically, like anything that has like a massive share state cannot be easily ported over to a state channel based solution. So and at the same time there were new ideas like rollups, and also like which was kind of based on the old idea of plasma, and that was like was being like brought up by Select Vitalik and like all people in the Ethereum community. And that's when we kind of like headed into the space, based on like what we already built the state channel, like can we also like do a roll-up solutions and kind of like combine the two for the best of both worlds kind of. And yeah, so and we didn't do a like general roll-up, and that was also like when the DeFi was kind of like picking up. So we did some what we call a specialized roll-up for DeFi applications. Basically, the idea is that we build this roll-up as an aggregator of all the DeFi protocols on layer one. So like people can actually interact with indirectly with the DeFi protocols on layer one on our roll-up, which we kind of like batch all their like transactions together and send them off to layer one. So that was like our custom built scalability solution for DeFi. So yeah, that was like the I think that was like late 2019, 2020. But then like I think we kind of saw like a bunch of EVM and like also now EVM chains popping up. So at the same time, so basically it was like when Ethereum gas price was skyrocketing, and also like Binance and Polygon came up with their like side chain solutions, and also there were a bunch of like optimistic grow up on the horizon, so like Arbitrum and Optimism namely. So and we thought like it would be great idea to like connect all those like EVM chains, side chains, like rollups, all those like different like EVM copies or EVM clones, right? So, and that's when we like ventured into this like bridging solutions. And in terms of like technical, I'll get into a little bit of like technical designs here. So when we first built the state channel solutions, one of the problems we hit was like for state channels, right? Like you kind of have to have this thing called watchtower to be able to like kind of like watch over the states, right? Because you have this like fundamental problem of if a user is like indefinitely like is off chain indefinitely, then and their stake can be their like funds can be stolen by the counterparty if they were like if this user, so like if Alice is like goes offline for like 24 hours, Bob could like submit a state from the past where like Alice would have like less fun than she actually has as of now. So that would be kind of like security issue. So you have to have someone to like watch Alice state. So in case like if Bob submits an old state and stale state, if Bob tries to submit that state on chain, like then the watchtower can just like counter with a newer state from Alice. So that would be that's called the watchtower problem. So to efficiently solve that, we built this customized sidechain called the State Guardian Network, which is a blockchain of it on its own, and it kind of like basically it's like a decentralized custodian of all the state channel, all the states on the state channel. So that was like, but like I mean the generalized state channel didn't really take off. So like we have this like blockchain running, and it's kind of like doing very minimally. There were like very few requests of like the state custodian requests, but it was fully functional as a blockchain on its own. So it was both on the Cosmos SDK, so like all good, all that. And like then when we're building this bridging solution, we kind of had this idea to like, why don't we just like reuse this like state guardian network that we already built and it's already running and functioning. Like we have experience of like building a customized like application chain, what we call it, right? What would they call it? Application chain. So we ported that functionality over, and then we added the bridging functionality on top of it. So basically, the state guardian network will become the like decentralized watchtower custodian for all transactions on all the connected blockchains that the Celer cbridge supports. So that is like a little bit of history of like how we ended up in the state right now. So yeah, we can go into like a little bit more details on like all how those components work. But yeah, so the main focus we have right now is obviously the cbridge, the bridging solutions. Yeah, and also like we are exploring the area of ZK to kind of like further enhance the security of our cbridge. So that I can like go into a little bit more on that.
No, we can. That was a whole lot to unpack. You know, it was, but it's exciting to see kind of your journey. You know, like it's, you know, you guys started out state channels and then moved into some things, and now we're doing bridges. And I remember Matic back in the day, you know, now Polygon, they were doing like plasma, and it was
yeah. Matic was also like we were kind of like started off. I think Matic was like we're like Binance like IEO, like I think we were like the third IEO or something, and then like Matic was like one after us, or like two after us or something. Like we kind of like started off at the same time, and yeah, they were doing plasma and we were doing state channels. It was like those two were like the like kind of the top like scalability solutions to go back in the day, but like neither of them kind of really took off.
Right.
So Matic just went like the full side channel and side chain solution, and they like acquired a bunch of like other companies to do like the ZK stuff. So yeah, I think they're quite successful in that regard. But we like kind of like venture into different areas where we did like a little bit like customized roll up, and now we do bridges. So it's very interesting, like how the journeys of like different projects went.
Yeah, and then so I mean, I guess we can get into start drawing. We can start drawing out kind of how the cbridge or state guardian network, I guess, works. But first question, you guys picked Cosmos relatively early on. You know, why did you select Cosmos over sort of building your own L1 or something like that?
Yeah, great question. So I think at the time, like our I guess the design goals were to not design goals, but like our product goals was to just have this sort of like a customized, like we don't need a generalized chain per se. So there were like different approaches we could pick, right? We could say essentially fork guess and kind of like just do everything in terms of like smart contracts and deploy basically like go the BSC route, whatever, right? Like we just fork guess and like kind of like write everything in terms of Solidity, like and maybe some like system contracts like for the custom like core stuff, and then that was one goal, and the other was like just pick one of the what they call like toolkits for blockchains, either Cosmos or Substrate for and to kind of build our custom chain. So yeah, we evaluated all those options and we found that I think Cosmos was, in terms of like documentation, in terms of like developer friendliness, and we were like most like interested in that. And mainly, like I think there was also a thing of like language choice. Like we were quite proficient, not proficient, but like we were quite experienced in Golang. So like all of our state channel applications like backends were built in Golang, and Cosmos SDK was mainly a Golang SDK. So we were very comfortable working in that compared to like say Substrate, which I mean Substrate was like a great toolkit but on its own, and it has like great like standard libraries and like all the goodness, like they're all like very also like quite ready, but I mean it was more in Rust, and it was I guess like the learning curve for like onboarding like new engineers was like a bit steeper than the Cosmos, which was more ready, and it also has like great documentation, great examples, like great cool code examples out there. So that was like the main yeah, the main reasons why we picked Cosmos.
You're fighting the Rust.
Yeah, I mean Rust was cool. Like personally, I like both. I mean they were just like so different, right? Like Golang and Rust, they were just like so different. Like
I don't know if they are, but
yeah, yeah. I mean they look different, like underneath the
sure.
But like yeah, there was like I guess no particular. I mean, like personally, I guess I do have a slight preference for Cosmos and their like way of doing things, and, like compared to what like I guess Polkadot was a little bit more complicated, and they're trying to be like more so for example, you have to like stake DOT, you have to like stake KSM for like to actually like launch a chain. So like we weren't quite sure if we were able like how much of a freedom we have. So like for Cosmos you can just build the chain, like you don't have to like necessarily buy like Atom or stake Atom. And for Polkadot you if you want to ever be one of the parachains, you have to like kind of like participate in those like bidding for the like
what's a shared security, which
shared security or that. Yeah. So we weren't sure we need like that kind of like shared security, because like the state guardian network is kind of like blockchain on its own, right? It doesn't have to be. I mean, it'd be great if you like it's integrated in like, for example, like the IBC or that, which it isn't currently, but like we do have the option to kind of like integrate with like make it more of a like basically move the Celer token over there, like make it more of a like IBC part of like part of the IBC ecosystem. That is also an option, but it's also something we don't have to do, right? So because like I mean the Celer token is on Ethereum, like we actually did design. I could go into more details on that. Like the entire like staking is kind of like special. The staking isn't.
Well, let's get into it. So I mean, I'm gonna pin myself here so people can see. So let's give a basic, so we'll have, Ethereum over here, and this will be your network, and this is where the Celer token lives, right?
Right. So yeah, is that like a diamond box, like a smart contract, or
I'm just representing the Ethereum network over here.
Yeah.
The diamond of Ethereum.
ERC20.
Yeah, and then this is we'll put this one over here. This is the Cosmos, or what do you guys call your chain?
We call it State Guardian Network, or you can call like you can write a Cosmos SDK based, right? Tendermint based chain. Or
well, this SGN. We'll do
SGN,
State
SGN.
Guardian Network, and then we'll pretend over here that this is. I mean, I know you guys are up on Filecoin right now, right? So like this can be like Filecoin.
any connected chain, or I think
Yeah,
FVM
this will be Filecoin, and let's say we want we want to bridge. The use case will be we want to bridge, some token from Ethereum over to Filecoin.
Sure.
So I guess how would we get this thing started? So first I'm guessing there would be some people who would need to come and stake here on SGN, right?
Yeah, for the security of SGN, like also like to kind of like make it more decentralized, we just like kind of like ported the Cosmos delegated proof of stake over, but we did a little bit of modification just to accommodate the fact that the Celer token is living on Ethereum. So what happens is that people would stake on a smart contract on Ethereum. So this is kind of similar in regards to how the Polygon staking works. Like people actually do the staking on Ethereum, and then the existing validators on the SGN chain will pick that up. So they'll kind of agree that, oh, we all see a staking event happening on Ethereum.
Okay, so there would be, I'm guessing you bootstrapped it with the team or something like that.
Yeah, we bootstrap with like the
Right.
the foundation nodes. So like the Celer like foundation has the initial validators, but we quickly expand to like third-party validators.
Okay, so these would be validators. And that's what these guys, basically they self-manage. Everyone is staked here in this smart contract. And then they basically say, yes, they are staked, right?
Right. Basically, they watch the Ethereum chain and then they vote on this event. Like this is a classical Tendermint consensus. Basically, the validators agree on the fact that we've all seen this like guy staking on Ethereum. So that is like how the stake gets reflected onto the Cosmos chain. So
okay.
Alice staked like say 1,000 Celer, it gets reflected to the SGN chain. Of course, after like a safe block delay. So like after say 12 blocks, right, which is the safe like Ethereum time for like the block delay. Then Alice stake gets like what we call synced, right, synchronized to the SGN chain, and becomes a standard like I guess Cosmos stake in that regard.
Cool. All right. Okay. So then now you have a group of validators, right?
Yeah.
And then if we're going to, let's say we have a token over here, we'll call it TRB because it's a good one. Let's say you wanted to go from Ethereum over to Filecoin. Would you, I'm guessing you would take these and you would deposit them into a different smart contract?
Yeah, it would be a different smart contract called for like TRB, what we I guess I'll divert a little bit on the two different models that the cbridge operates. So
sure.
Like one model we have is we have liquidity pools on all different chains, and those are mainly for what we call like a blue chip or like a very high like a market besides stable coins and Ethereum. So those are what we call like blue chip or like a very high market value market cap coins, and those we do with liquidity pool based bridging models. So what we have is like different pools liquidity pools on different chains, and then like they kind of like can swap across each other. But for TRB and like most of the smaller like market cap coins, what we do is we call like X assets, which is this like lock and mint kind of model. So basically TRB gets locked into this vault contract. So this is like a vault contract on Ethereum. So we'll call the original token vault. Yeah, that's like kind of technical term for that. Yeah.
Cool. Okay, so it gets locked here. And then these validators pick up on this message, right? Or
yep, the validators exact same way as they would watch a stake event, right? They would watch the vault contract for this like lock event.
Okay, so they would look, and then they would get event, and then they would pass it over to a smart contract here,
right,
which would then mint over here.
Yeah, exactly.
And that's the most simple bridge that you could possibly have, right?
Yep.
You know, as far as to run a diagram, I guess it just gets into, you know, so I guess what is preventing these guys from lying is the question.
Sure. I mean, yeah. I mean, they can lie. Like one of them can lie, and we do have like a slashing for that kind of situation. So if one like a malicious validator is discovered, then the other validators can slash them by just like voting them out and like slashing their stake. So that is like standard for just like DPoS kind of chains, right? That's
so this would just be a normal Tendermint, you know, like somebody would basically, they're listening, one of the validators would, I'm guessing, grab that event and say, this is a new event. As long as all of them agree, either they slash the guy for proposing a wrong thing, or they go forward and say that it's a good thing, right?
Right. So yeah, so the security guarantee is that you have to have like, I guess 2/3 plus 1, like the 3F, the like a classical 3F plus 1, right? Like you have to have that like above that threshold of good guys, right? Otherwise, you do have
above 2/3 plus 1.
Right. That is like the standard Tendermint like security. We don't like in this version we don't try to go like more secure than that in any regard. So yeah, the standard Tendermint security threshold.
Okay, and then I mean, and then what would be? I guess the question over here is how does the FVM know who's allowed to push to it?
Well, so when you mint, right? So like on that mint arrow, like it has to check the validator signatures. So it has to check like basically, yeah, I think that's one of the interesting design decisions. So what happens is that the staking situation, the validator, the list of validators associated with their voting power were periodically synced to all the connected chains, so that they can verify that the I mean with some sort of, it's not like in real time because otherwise the cost would be too prohibitive. So periodically all the staking information, all the validator info along with their voting power are synced to all the connected blockchains, including the FVM. Yep. And with that info, like whenever a mint event happens, right, the mint message will contain the most up-to-date validator info and power. So like those have to match whatever that is on the FVM. So yeah, so that is like the security guarantee that it's not like arbitrary, like anyone can mint kind of situation.
Sure. And then, so basically the way that you would want to attack a bad Oracle value, like, well, I guess it would check, would this have to be a signature of just one of the validators or all of the validators?
No, it has to follow the same, it basically runs the same like Tendermint 2/3 plus 1 2/3 plus 1 secure like a threshold. So basically it has to check that greater than 2/3 of the voting powers voted for this mint message. It's not like any one of them. It's not like because otherwise it would not be very secure.
But I mean, like, who's the address that's allowed to push it? So like on an EVM chain,
no, anyone can push it, but like
anyone can push it,
right? But I mean, they have to like gather enough signatures, right? They have to gather. So like like anyone has access. Anyone who has access to SGN like RPC can actually push it.
And then how many signatures are we talking about here? You know, like what would be, you know, like is this hundreds or thousands?
Well, I think, yeah, technically Cosmos can support say like up to 100 validators, but as of now in production we have I think around like 25 some like validators and with decentralized stake. So yeah, usually like for like you don't need all 25 signatures. You probably need like I guess 15 of them or something, depending on the staking situation. So it's not like 2/3 of the number of validators. It's 2/3 of the number of stakes, right? So like you have to like kind of like I mean, I guess if you gather the top validators and they're all good, then you don't need all 25 signatures. You just need like say maybe 10, maybe 15, depending on the staking situation.
So if you had like one gigantic staker, you could technically just have one.
Yeah, that would not make the like network very decentralized.
Right, of course.
Fortunately, we don't have that. Fortunately, we don't have that kind of situation, right?
Sure. I mean, and then what would be the stake amount? Can you come in with any stake?
Yeah, you could come in with. I mean, if you were to like corner the market, like buy up all the Celer tokens like stake, then so be it, right? So yeah, there's no.
That would be the way to break Celer would be you go buy all the Celer tokens, or you go buy the amount that's this amount, 2/3. You stake them, and then you can wreck the validator network, right?
With a little caveat that we do have like rate limits on all the smart contracts, which are independent of how the SGN works. So like we do have security measures on all the basically we kind of have this like rate limit parameters, like actually different kinds of like rate limits in terms of like how much token can like outflow from a network, how much token can inflow into a network, all that.
Okay. So you would say like you can only input like 10% of the total amount every day or something.
We don't have an upper limit for staking as of now, which it would be great to have, but I don't think any of the Cosmos chains have that as of now. So I think that would be an interesting security feature to add. So basically, you can't have like too much of a stake fluctuation. You can't have like massive withdrawal, so you can't have like massive staking. So that would be great to have. But what I'm talking about is like you can't try to bridge all the supply of TRB from like Ethereum to FEM because we have rate limits, and like like every 30 minutes you can only bridge like this much. So that is like one kind of like last line of defense against like the malicious SGN, like SGN being taken over by bad guys.
Well, I mean, like if the SGN's over, the attack vector for all bridges is basically just to say like I unlocked it all, right?
Which we do have like rate limits, and that's like the rate limit I'm talking about. So like you can't actually lock them all because we have like I mean the smart contract reverts like if you're trying to do that, right? The smart contract only allows like this amount, and like I mean it never happened, but like that is like the last line of defense. So
yeah, so then technically as long as the amount that you could unlock and mint on all of the tokens within that's under the rate limited period, as long as that amount is less than the cost to take over the SGN network, then you're solid, right?
Right. Yeah. Yep.
Yeah. Yeah. So I mean, if you guys have 25 validators, I mean, what percentage of your token is staked now, if you don't mind me asking?
Let me just check real quick.
Sorry.
It's a very high
yeah
percentage because like Celer tokens like we're not inflationary. It's it has like 10 bill as a maximum amount. Yeah, it's about like 3 bill is staked right now out of the 10 bill. So yeah, it's a little bit less than like the average of the Cosmos networks. So
okay, no, that's cool.
Like 26%, 30% ish. So yeah, I mean, ideally we do want to like boost that to probably like 50-60% so be in line with other Cosmos networks chains. So
yeah, but I mean, I think it's like a different paradigm than like you know, like a Cosmos, for instance, most Cosmos chains, even if you're limited on the validator set, then it's not like an Ethereum where you want more solo stakers, right? You guys would more so just want giant validators, correct?
Right. But we do want like more Celer token to be staked. So as because I mean, the more you're staked, the less possibility that someone can like buy up all from like secondary market and like and activity attack or whatever. So yeah. But the thing is, like the Celer token isn't inflationary, and like the staking reward isn't as high as some of the Cosmos like chains because they can like issue new tokens. They literally like mint new tokens in their code, right? So and we don't like mint tokens. Like all the staking reward pool come from like the like foundation reserve like staking pool. Like and we do want to be like a little bit economic on that. Like we don't want to just like I mean yeah.
So most of these are staking pools, would you say?
Well, no, I'm saying like the reward of so like you do get like a little bit like a Celer reward on top, and we'll get into the feed like sharing details later. But I think like what they call like real yields. I think the Celer cbridge is some like source of real yield because you like all the stakers, all the delegators do get a share of the bridging revenue
Yep, because like whenever you I think it's whenever you lock, you have to pay the fee, right?
Yeah, whenever you're trying to bridge over, yeah, whenever you lock, you kind of have to like the amount the amount you receive on FEM is a little bit less than what you locked, and
Yep.
the difference of that goes to the fee for for the validators, for the delegators, and
Yep.
yeah, and that is like the fee model. So yeah, in terms like that, like in that regard, I think that the stakers do get like part of the real yield, what they call it, because it comes from like a real usage. And on top of that, they also get a little bit like a Celer reward, but those are not like, because Celer is not inflationary token, those were not like minted out of thin air. Those came from a limited staking pool that was reserved by the foundation, right? So like
Okay.
that was the one I'm talking about. So yeah, in terms of like the Celer token like APY, it's not as high as some of the other Cosmos chain, because for like most of Cosmos chains, you do the best yield you get is just like stake on network, and that's the best yield you get. For Celer, it's not the case, and it kind of depends on the bridge usage. If the bridge gets a lot of usage, you get a bunch of like real yield. Like the majority of your reward comes from this the bridge fees. So
I mean, are you even competing with people for like yield on Cosmos chains? Because I mean, for you guys are staking on Ethereum, right?
Right. No, we're not. I'm just
Yeah.
like, it feels like security, right? Like, because for Cosmos, they do target like, I believe like 60 to 70%, like a percent of their token stake. I think that is like the average of most Cosmos chains. But yeah, we're not trying to compete with them. I'm just saying like,
No, I'm cool with it.
if we were to like get to that kind of like percentage, I mean, the Celer token would have to be like inflationary or whatever. Like we have to like allocate a larger staking pool, which like the foundation doesn't really have, right? So yeah, so we're trying to like boost the real yield, and that's like if the bridge gets more usage, if people are like bridging, say like TRB back and forth, the USDT back and forth all across all the chains, then the stakers do get like a larger amount of like bridge revenue from that. So like we don't have to basically, I mean, the real doesn't like the majority of the reward doesn't come from inflation. If it comes from the bridge revenue, then that would be the most ideal situation. So yeah,
For sure.
mm-hmm.
Cool. I guess what else can we add about the bridge? Anything?
Yeah, so that is like the token bridge, and we actually do support generalized message bridges, like all on the same architecture. So
yep.
Yeah, instead of locking TRB, you send an arbitrary message, and yeah, you don't send it to a vault contract. You send to what we call like a message bus contract. So basically, you can say, for example, you want to do a cross-chain swap, you can send to this like message bus contract a message that says like I want to buy TRB on FVM, on a swap on FVM with this amount of USDT. So like that is like a generalized message that gets passed to the message bus contract. And then the rest will be pretty similar. Like the SGN validators will watch for that message and then relay over to FVM. And there's going to be the same like message bus contract on FVM, which is the RX side. So that the first one will be the TX, right? This will be the RX side. And then
cool.
This message gets further relayed to the swap. And if the swap implements our generalized messaging SDK interface, then they will be able to process the request and complete the cross-chain swap. And you can actually send the money back. You can, like with the TRB bot, you can they can send a reverse message, a receipt message back, and along with the tokens. So back from FVM to Ethereum, so that the user can automatically receive the TRB like bought from another chain. So that would be the complete workflow of this cross-chain swap.
Nice.
Mm-hmm.
Yeah, no, that's super cool. Yeah, so because I mean a message, basically, I mean a lock is a message.
Yeah, we when we built this out, we didn't actually build the token bridge on top of the messaging bridge, just because like message does have a little bit like a decoding, encoding overhead and all
Okay.
that. So like a specialized token bridge, I mean, it doesn't cost much on SGN. I mean, because SGN is just Cosmos chain. Like you can add more, like you get more leeway than like say an Ethereum or like something that is like more gas metered. I mean, yes, the Cosmos is also gas meter, but it's like you can put more complicated logic in the Go code than like trying to write solidity for all those. So yeah, we could build a token bridge. I think we do have a version that's not in production, that basically the token bridge on top of message bridge, and that's all like doable. But yeah, for the current production version, we have two separate systems for token bridge and messages.
Yeah.
Yeah.
So I mean, you need. Because I mean, what's the cost to do anything over on Cosmos? It's really, really cheap, right? Because
yeah,
you guys, you would need, I'm guessing, like 15 validators at least to sign every single message that passes through, so you can push it over.
Yeah,
So
the amount of work that validators actually do are quite minimal. I mean, they're just like I think most of the costs are coming from for us. I mean, I think most of the costs will come from like for example, sometimes like some chains have like rate limited RPCs, and you have to like buy like yeah, also or just like run your own full node for those chains, and those were like the biggest operational like overhead. But in terms of actual work, that they do, it's quite minimal. Like it's just like watching the events, like and like sign with their like validator keys, all that. So
nice.
Yeah.
And then do you slash them? How does the slashing work? If I can ask you.
Yeah, so slashing is it's just as I said, as I touched on it a bit before, so like all the validators can vote to like slash someone based on some kind of like evidence. So if I mean, of course, there's like the standard there are like two standard types of slashing for the original Cosmos. So you have like validator being offline for too long. So like so like the past 24 hours, like the validators could like one of the validator can miss a bunch of blocks. So like by being like offline or like having a spotty internet connection, they could like miss a bunch of Tendermint blocks, and that is a slashing condition. And the other one, which is more severe, is that they're trying to like do double sign, like they're trying to sign two different versions of a block. Yeah, I think that is, I think in the Cosmos terminology, it's like infraction versus felony kind of. So like, yeah, infraction would be like being offline for too long, and like felony would be trying to like double sign. So those are the two standard Cosmos based sessions. And for us, it's we added the if you're trying to like basically if you're trying to submit some invalid message, like invalid event that never happened, like basically if other validators don't agree that like that they've seen like someone locked. So like if you're trying to like one of the validators trying to say like someone locked a bunch of TRB, which never happened, right? And the other validators can vote to. So that is like a customized like slashing condition we added on top of the Cosmos ones.
And then, I mean, is that pretty automatic? Like if I fork the chain and do a fake send TRB to lock and then send it here, how long until I'm slashed?
It'll be like very obvious. I mean, as soon as like the other validators discover, it's quite like it's like almost I won't say instant, because you still have.
And then are you slashed the full amount?
It's a little bit complicated than that. So like I think in terms of like we kind of like copied the Cosmos like terminologies for infraction versus slash versus felony. So like they have different percentage for slashing. It's not the full amount. I don't think it's the full amount, but it's a pretty significant amount of their stake. So
nice. All right, and then. No, that's really helpful to know. And then I guess one more question I have: anything else the Celer token's used for? Is there any sort of governance role in it? Does it do anything? Or is it just staking?
Yeah. So we like all the decisions to like alter the for example, like we do have a listing process, what we call for the cbridge. So it's not like you can come in with a like arbitrary new token and then like SGN is not going to support that just yet. So you have to pass this like governance process to get listed and recognizing SGN. So that is also a security feature. Essentially a whitelist, right? Because you do have a bunch of like tokens that are like say like meme tokens. They have like burn taxes, all those like features that we don't necessarily want to support. And like so for like any new project to come over to be able to like for any new project to be able to like bridge via Celer, we do have this like governance process where all the like stakers vote with their Celer token. And
so it's these, like, it's not the Celer token holders, it's actually just the people in this contract.
well no, it's so it's a delegated process. So like all the validators. So currently, like just all the validators vote on the proposal, which.
So if you're going to whitelist tokens, you put forth a proposal and it gets approved by these guys.
Right. So yeah, I mean, the voting isn't like we don't actually sync the voting process between Ethereum and SGN as of now. So yeah, it's a little bit less ideal, I guess, because it's more like delegated. It's more of like a cabinet based voting system. So basically, like the voting only happens on SGN. So like the proposal it's a standard Cosmos proposal, but the voting is simplified in terms of I think it was a design decision to like not requiring users, not requiring like a regular like retail stakers to like also create an like SGN account, right? I think that was the design decision in the beginning. It's like all the stakers, all the like little stakers can just use like MetaMask, and they don't have to like create a SGN like a Cosmos account. But the downside is that like all the voting will be delegated to the validators. Like whatever like validator they delegated their tokens for will do the voting for them. So like they don't have a direct say. So that is like slightly different from the standard Cosmos voting process, where like each individual staker do have a voice like directly in the proposal. But for us, it's more like validators like gets like that delegated the delegating responsibility for like all the voting stuff. Yeah, so like the voting, like someone will propose, usually the foundation, and it could be someone else that can propose it's like a listing proposal for say TRB on SGN on SGN, and then like all the validators will vote, and that part is the standard like Cosmos based voting. And then after currently is like 12 hours of voting period, and sometimes we lengthen that, sometimes like we shorten that based on like the staking situation. So after say like 12 hours of the voting period, right, and the proposal can get approved or rejected. And usually it's approved. Like we already like as the foundation already like vet all the projects. We don't list like random like scam projects on that. So.
And then I mean, can you unwhitelist them? Because I guess that's a risk for people too. Yeah,
we can. I mean, it's not like it's more of a sometimes like a project can like wind down. Sometimes a project can like pull back from their like bridging needs. Like sometimes they'll say like, oh no, we're just gonna like pull back to one of the chains. Like we don't want to go multi-chain anymore. And then we do have a delisting process, which like we unwind. Basically, we if possible, we would tell them to like unwind all those like minted tokens on other chains and get back to the original token vault. And then we have this process to like list write a proposal to deregister the token from SGN, and then it will be completely safe. Like any further like attempt to bridge them will be ignored by the SGN. So yeah,
cool. Yeah, so I guess the next question would be, what are you guys doing next? You know, what is this going to be? What are you guys doing to make this better, or are you focusing on something?
So yeah, we did launch a new effort called the Brevis. So like we call it's a BREVIS, Brevis.network, which is a ZK it's a zero knowledge based data attestation platform. So yeah, it's a mouthful, but I think it's sorry, it's Brevis, not C. Sorry, Brevis. I think it came from like Latin. I think it came from Latin for like
So not, is there an E at the end or no?
no E, no E. Yeah, just
No
Brevis.
E with an S, brevis.
Brevis or Brevis. I don't know how to pronounce this like Latin word. It's part
Brevis, yes.
Yeah, so it's a ZK based data attestation platform. So basically, what it's capable of is it's using like a Snark proofs or Stark proofs to prove things that or otherwise have to be proven like using traditional computation. So like one of the application would be bridging. Like you can actually like instead of having validators like attest that something happened, you have this like mathematical like Snark proof to show that someone did lock this amount of like TRB token from Ethereum. And it is more computation involved just because like you first have to prove that this like Ethereum block happened, right? And then you also have to prove that the TRB locking transaction is part of the block. So yeah, it's kind of like much more involved than just like having like Alice and Bob. I mean, not Alice Bob, but like having validators like this, for example, like the Celer validator, the Binance validator, just like voting on that. So yeah, computationally it's more expensive, but in terms of security, it's much more improved than this current model.
So basically, you would take this and it would say, you would take this event and create a zero knowledge proof out of it that says this happened, and then just submit the proof over there.
Right.
Almost
exactly.
rather than the signatures, it would be a proof.
Right. It will be a Snark proof of both like the Ethereum header, the Ethereum block header that contain the event.
Yep.
So first, like the FEN has to know that like this Ethereum block happened, and also it has to do the like a little bit of the consensus. Basically, it has to do the fork choice, right? If you have two like different Ethereum, the different versions of the Ethereum blocks, you have to decide on which one is the canonical chain. So that is also a complexity in this. And then like you have to have this like transaction proof of this like TRB lock transaction being part of the canonical Ethereum chain.
I mean, does that necessarily change any of the trust assumptions though?
Well, I mean, it's not like 100% like trust free. I would say it's trust minimized in that like you still have to have like at least one honest like block header relayer, right? Because otherwise, if every single relayer in the system is malicious, then you still like if basically you can end up in a situation where like FEM only sees invalid Ethereum blocks or like something that is not on the canonical chain. That is entirely possible if you have like none of the like if you have like zero honest block header relayers. So yeah, the trust assumption is that you have to have at least one honest block header relayer.
So it's almost like you would need to trust a bridge like Cosmos already to be bridging over the Ethereum block headers, right?
Well, yeah, that is one way of doing that. So basically, like, but the thing is, like, I guess it would be more obvious if, like, someone. I mean, yeah, you can have like different types of design decisions in that regard. So you can have like a period where anyone can submit like honest. You can have like a yeah, but the thing is like it's kind of like hard to like do a challenge in that regard because you can't really tell from a like invalid block. You can't tell from an invalid block from an invalid block, right? It's not that easy to do that. So basically, you have to trust that like someone in the world like is going to submit an honest, like correct Ethereum block header to FEM. But I think that is still like that kind of a trust assumption is still smaller than like say the SGN not colluding and like or like the SGN not like basically like forging an TRB lock event. I think it would be more
just makes it more obvious, I guess.
Yeah, but you're right. Like it doesn't like fundamentally it's not like trust free. It's just like trust minimized or like less like trust assumptions than the current model. So
cool.
Because I mean, for the actual like TRB lock event, we do have a Snark proof for that, right? It will be like that part you can't forge. I mean, just because it's based on like Snark and mathematics and probability and all that. So
yeah. Well, I mean, but even with Snarks, you know, like you could, it all. This one just comes down to who's, you know, whether it's now it comes down to you guys putting on the correct information, but in this one, it comes down to who's the person that's doing the block relayers, you know, and that's actually the bridge you care about now.
Yeah, that's true.
And is that trust minimized? And, you know, so then you would have to analyze that bridge rather than this one.
Yeah, I think from a like I guess theoretical, like more strictly like strict terms of like this is not like trust free, right? This is just like different trust assumptions, and you can argue whether it's like trust minimized compared to the current model. So yeah.
Well, I mean, like in a roll up that like grabs state proofs from Ethereum, or do they? Or
sorry, what? You mean like the rollups, or
do rollups like already get the block headers from Ethereum, or?
No, I don't think so.
I don't think so.
Rollups are more about like bridging
the other
their
direction.
like just like saving their state, like saving a checkpoint of their state, like a snapshot of their state. So they don't actually do any kind of attestation for anything on Ethereum. So yeah.
No, I've always said, like, I think a lot of bridging could be, you know, made trustless if like just if the FVM validators just like included an Ethereum, you know, all the Ethereum blocks in their validation process, and then it would make your guys' job easy and trustless. But anyway,
some bridges do actually do that, right? Some like I think for like the Rainbow Bridge on Near, they actually validate Ethereum headers on Near, which because it's I mean it's cheaper, it's feasible to like validate Ethereum headers on Near, right? Because otherwise, I mean because like Near is similar to like a Cosmos, right? It's just like a blockchain they build themselves, right? They can like add arbitrary logic, and they can like they get to decide like how much gas it costs to validate the headers, right? So if they put more like priority on that, they can actually like arbitrarily just lower the cost and make that part of their like core consensus to like validate.
No, I think everybody should do that, and then you just have Ethereum as a hub. And then
that would be like a very ideal vision.
Yes,
I mean IBC is like one like an implementation of that, right? All like Cosmos chains interconnected. They do validate like the headers of each other. So and as part of their like core consensus. So
well, and there's some people are working on doing IBC with non-Cosmos chains, right?
Yeah, I believe so. I think there are people doing IBC for porting IBC over to Ethereum. It's just like more there's more like design challenges, because like listing like Solidity, then like you have the gas problem, right? You have like you try to validate a bunch of signatures and like a bunch of headers, and it's not like cheap, right? So yeah.
All right. Well, I'm going to be cognizant of your time because I know we're running up on an hour, but you know, like where, you know, I'll ask kind of the first question, you know, like what Oracle design, what do you wish you would have done differently, you know, 2-3 years ago when you were building some of these Oracle bridges type systems, you know, like what's a misconception you had and something you kind of learned along the way?
I would say misconception. I would say like I guess like security assumptions. Like sometimes I mean we did get hit with one of the security incident from Harmony. So the thing is like the official Harmony bridge was hacked, and then the thing is like that made the USDC the like basically the Harmony officially bridged USDC worthless essentially, right? So and we did get hit by that just because we added that version of USDC to our liquidity pool model. So because the security assumption was that like all USDCs are the same on all the chains, and we weren't prepared, I guess, fully prepared for it. We were prepared, like just like with the rate limit thing I'm talking about. So like the losses to all the liquidity providers were quite, I won't say minimal, but like we're limited by the rate limit, just because like we did have a hard cap on like how many like Harmony USDC can exist in the system. So it's not like the Harmony USDC get like taken up by it's not like other USDCs get swapped to the Harmony USDC and effectively became worthless. So it wasn't like that, but it was like limited to like low few like $1 million. It was a big loss, but like it wasn't like uncontrollable. So yeah, but that was like the wrong security assumption we had, was that like all official bridges are like safer than like I guess or kind of safe. They're not safe, right? I mean, Harmony bridge was hacked, like the Binance bridge was hacked, like the Polygon official bridge was hacked, and so like yeah, so that was like something that we should have done better, and like had more like stricter like basically the idea is that you can have like two different tiers of blockchains. You can have like more trusted chains like Ethereum, like and for example, like Ethereum Binance chain, those can be put into like tier ones, and like those like some other chains, like newer chains, can be put into tier two with stricter security measures, like I guess lower like rate limits, all that. So yeah, that was like one lesson we learned during the process. So
Nice.
but I think in terms like fundamental like technical decisions, including the choice of Cosmos SDK, we're very happy with that. So yeah, building on Cosmos SDK was it was a pleasure to actually build stuff in Cosmos SDK, and we're still very happy. And we were very happy to actually see like the Cosmos ecosystem grow from what we worked on back in like say like 2018, 2019. So it was still like I mean, it had good documentations, all that. It still kept that kind of tradition, but now it gets expanded with like the actual IBC and like share security, all that, like all the good stuff are coming also. So and we might like look into those in the future and make the SJM more like full-fledged and actually like allow end users to have a Cosmos account and port some of the Celer tokens over to SGN. So that is one option that we are looking into, and it's yeah. So yeah, in terms of technical decisions, there's nothing to regret about, and like we're very happy with that. Yeah, every technical decision exactly, and yeah, it was quite a journey. Yeah,
For sure. Yeah. No, it always is. And then yeah, anything people can. What's the final thing to end with? What's to look forward to, and where can people go to find out more?
Yeah, so I mean, I guess you can always like look up on our documentations, and we have quite extensive documentations on all of that. So if you just Google like cbridge docs, I think it will bring you to that page. And also check out brevis.network, which is our like we do have a new white paper for our like entire ZK effort, and we have a little demo of it's not based on SGA, it's just a simple like token bridge across two, I think it was like BSC testnet and Gertie and Ethereum Gertie testnet. So to kind of showcase how like the ZK bridge would work, but it's not like based on the current system yet, so it's not integrated yet. Yep. Yeah, check out brevis.network for our ZK efforts, and hopefully we'll be integrating that into the existing bridge to make it more secure. So you kind of have to. Yeah, I mean, maybe sometime we'll have like some of the validators to like run the ZK proof, and they'll get like more of the reward. And I mean, you want to do more work, you get more reward, and
yeah,
and also require the signatures on top of like the ZK proof, so that it gets like best of both worlds kind of. So yeah, it could be a vision we'll have in the future. So yeah,
super cool. Anyway, yeah, so. Thank you for coming on, and yeah, I'll bring you on next time, and you can explain the ZK stuff. So
sure.
let's see.
Thank you.